Hello friends! We are Group 3! My name is Miftahudin.
My name is Rifqy Fadlillah.
My name is Nurani Apriliana.
I am Maylafayza Salsabila Zen.
Today we will discuss a very exciting topic that appears quite often in transportation problem. Let's keep watching!
Hello friend! So today we will solve this problem. Solve the following transportation problem with A. Apply the transportation algorithm directly to the given table without adding a dummy. And B. Modify the table by adding a dummy column to balance total capacity and total demand. A and B, we solve the problem and determine the total transportation cost. And then after that we conclude the true or false the assumption that the total capacity equal total demand in the transportation problem algorithm is critical. So let's go.
Hello friends, today we will discuss how to solving the transportation problem when the demand and the capacity are unbalanced. But like the problem part A, we don't immediately a dummy in the beginning. So let's see what will happen. So in here, we start by organizing the data into table 1. And we know that we have the three of the sources that are A1, A2, A3 with the capacity of 10, and have 4 destinations that are T1, T2, T3, and T4 with the demand of 6. Okay, so the first step, we must subtract the two minimum costs in each column and each row. So let's see in the column 1, we see the two smallest is 1 and 4. So we just subtract it to the value. So we get 3 in here. So we also subtract the minimum 2 costs in another row and another column with the same ways. This is get 0, and this is get 1, this is get 3. So for this row we get 3, and then we get 0, and here we get 1. So the two difference between two small costs in each column and each row is called penalty. So for the next step, we must choose the largest or the maximum penalty in here. So in here we can choose 3 for the maximum penalty. That is the occurs in the T1. So for the next step, for this column, we choose where is the smallest cost in here. We can see the smallest cost in this column is 1. It's 1, so this is occur in the C11. So for the next step, we find the maximum allocation for this in this cell with the minimum of 6 and 10. That is the minimum between the demand and the capacity. Okay, so we will see the changes in the table 2. Guys, in here. So guys, for the next step, it must same like to before. That we must find the penalty in each column and each row. So in here we don't have any, and then for column 2, we see the two smallest costs in this is 4. So the difference it must be 0. Here the difference must be 1, and this must be 3, and this must be 1, and then it must be 0, and it must be 1. So like before, we find the maximum penalty in here. We can see the largest or the maximum penalty is 3. So this is the max penalty. we can write in here max final T is 3, that is occur in the column 4 or in the T4. And then for next, we can see where is the cost, the minimal cost in the T4. So the minimal cost is 1, that is occurs in C34. So for the next, we must to find the maximum allocation, minimum between the demand and the capacity. In here, the demand is 6 and the capacity is 10. So the minimum between them is 6. Okay, so let's see the changes between the table 2 and the table 3 in here. So, like before, we must have the same way to define. First, we find the penalty in here, like in the same way. We must first choose maximum penalty in here. So we can see that the maximum penalty in here occur in this row. So this is the maximum penalty. This is occurs in the row 3. Like in the A3, the penalty is 2. And let's see the minimal cost in the row 3 in here. So the minimal cost in this row, it must be 2. That is occur in the cell 3. So we can find maximum allocation to cell 3 and 3 with minimum of demand 6 and capacity is 4. So the minimum is must be 4. Okay, so we must go see the changes in the table 3 in view. Okay friends, so let's see the changes from the table 3 in the table 4. In here, same like before, we must first to find the maximum penalty in here. And then we can see that the maximum penalty in here is occur T3. This is the max. And we must find the minimal cost in the T3. So we can choose the cell 1, 3. So from find the maximum allocation to the cell 1, 3, we must find with the minimum between the demand and the capacity. In here, the demand is 2 and the capacity is 4. So to allocation cell 1, 3, it must be 2. Okay, so let's see the changes in the table 4, in the table 5. Like before, we have to do the same way to define the maximum penalty. We can see the maximum penalty is 5. There is maximum penalty that is occurs in the row 18. We can write in here. Penalty is 5, 8. Since there's only this, we must choose this cell, right? In here, we get the minimum between the demand and the capacity. So the demand is 6 and the capacity is 10, and the minimum of one of them is 6. Okay, friends, let's see the change in here to the table 6. We got this table. Let's see that all demand is 0. Its meaning it's already fulfilled. But there is this unused capacity left over in here. There is 2 in the row 1 and 4 in the row 2. So since there is the remainder in the capacity, we must add the dummy in this case.
Okay, we have this program before, and then still have the capacity 2 in A1 in the row A1 and row A2 in the capacity A4. Then we must add the remaining capacity program. But if we directly add the capacity in this program, so we not have remaining demand because our demand of the column is 0. Then we must add the dummy. So the dummy is have the demand 6 because the difference of the demand before and the capacity before is 6. Because the demand before have 24 and then the capacity have 30. So the difference is 6. Then the dummy is have demand 6. And then we know that the demand capacity in A1 is 2 and A2 is 4. Then we add it in the dummy. Like this. Then we have the demand in the dummy is remain 0. Here is final product. But we must say it is the final or it is the optimum program or we have another more optimum program. So we have to check it with our demand. In what you have plus k equal c r k. We let the r1 or the value of a1 is 0 or the value of row 1 is 0. Then with row 1 is 0, we can get the output connected with row 1 is the column 3 or K3 and the dummy and the column 1. Then we can know the value of K1, K3 and K dummy. Then we have R1 plus K1 is equal to cos 1 1 or this is a small rectangle in here. If the L1 is 0 and plus K1 equal to C11 is 1 or cos occupied cell 1 is 1. Then you can know the K1 is 1. Okay, we already find out the value of row and out the value of column. With the row 1 is 0, row 2 is 0, and row 3 is 1, and then the column is the K1 is 1, K2 is 0, K3 is 3, and K4 is 2, and the dummy column is 2. Then we add all the value from in here to this table. Okay, and then next we put the value of R and K in this table, so we can easier measure the quantity table. Then this is the output value of K with K column and R with R column. And then next we measure or we find our quantity table. This in here the unoccupied cell. This calculation with this formula R. The value of row R plus the value of column K minus by the cost of the unoccupied cell RK, like A1 to A1 to 4 is unoccupied cell. Then we calculate and define the OC or opportunity cost like this, and the program is still not optimal because the OC have positive value 1 and the figure of positive value in it is 1. So this cell must be occupied cell or not be unoccupied cell. And then the next we must have the require program with the loop so we can find the more optimal program. Okay, the different program we must fill the out-of-bed cell 1.2 or in row A1 and column 2. So here we have the evaluation. Then we used to look is start from here, and then we go down in A2 row 2, column 2, and then we move in here, and we move in here, and we move in here, and then we go back in the A1, T1, T2, and then we with the loop we can have the A1, T2 is because the minimum value of our the root in the loop is 2, then we fill A1, T2 in. Because if you this with 2, then we must subtract in the cell with 2, then we get 4 in here. Then we subtract this with 2, and then we must add this cell with 2. Then we have 6 in here, and like before in this. So we have 4, and in here because this have the optimum solution because in column T3 we have 2 and 4. There is in here we have the given is 6 already 6. So we not take this value in this cell, and then we have 2, 4, 6, and 4 in this. That takes the value of this program, and then we will your program with in here. Okay, we have the new program. This right here. Okay, we next to check the motif of this new program. Okay, we check the motif of our new program. Is we have planning board, the like formula, and first we let the R1 is 0, and we find all of the value of row and value of column. Then we add this value in this new in this table in this program. Then we have A, F, R, the value of row and the value of the column. Then we calculate the OC given the opportunity cost, and then we with this formula and of the unoccupied cell, if the OC is always negative. So this program, the new program we have is optimal program. Then the transportation with the dummy is still must we have asked the dummy, and then we have the new program. The optimal program is right.
Hello friends, we are still in here with the same problem as the case, the transportation problem, where the demand is not equal to the capacity. So previously we tried to solve this problem without a dummy, and then we can find the optimal solution. And now we want to try with dummy at the first step. Okay, are you ready friends? Okay, let's try it. First, we have the table here, the same problem that is contained A1, A2, A3, and T1, T3 with different demand and capacity. So first, we add the dummy column because we want to make the demand and capacity is the same. We can write 0 here, 0 here, 0 here, and because this is the sum of capacity is 13 and the sum of demand is only 24, we need 6 together. We can put 6 right here, and now we have the same demand and capacity. Okay, I hope you know that for the initial program you need some method, same like previous case. We use the double fund, and based on the fund we must be find the penalty by find the difference between the minimum cost. Okay, from this row 1, the minimum cost is 0 and 1, so the difference is 1. Okay, this is the PK and PP, at the difference of minimum. Oh, we forget about this one. Yeah, 0. Okay. The first one we must be check the maximum of the PP or PK, the maximum penalty we have. Okay, we have the maximum penalty is 5. Yeah, this is in row 2. we can write here. And based on row 2, we find the minimum cost in row 2. And the minimum cost within 5 and 0, yes, 0. And after we know this, we want to find the maximum allocation to put in row 2. The maximum allocation is the maximum between 6 and 10. So the maximum is for this column is only 6. Okay, now we have the maximum allocation on this cell, that is only 6. And we want to find the capacity of row 2 by adjust the capacity. So you can write satisfy the demand is only 6 and the capacity is 10. So we know the capacity for row 2 is still 4. Okay, now we move to another table 2 that we want to process the operation before. Now we want to find the PK and PP again by choose the minimum in the row and just be applied in this column, so we don't use anything here. Then we want to find the maximum penalty in this PK or PP. So we have the maximum is 3 and we have 2 columns. So what we will choose? We choose whether for which one, but I will choose the column 1, P1. And now we do the same way. The minimum for column 1 is in 1 in C1 1. Okay, so we choose the A1 and C1 C11, and we want to find the maximum allocation by find the minimum demand or capacity in here. So the minimum is 6, we choose 6. So this is still 4 because we must allocate in this demand, that is 6. So okay, we move to next table by process this operation. Okay, before we have a table 2 right here with this operation, and we move to table 3. And the PK is the difference between 4 and 3 is. We want to find the maximum allocation of this BB and PK by find the maximum. Okay, the maximum penalty is 3. Okay, this is the maximum penalty, and just write 3 here. In this T4, and we find the minimum cost is in A3. We want to find the maximum allocation. So how many allocation we want to put in this A in this cell? That is by check the minimum of this is 10, the capacity is 10, and the demand is 6. Okay. Next, we move to another operation in table 4. Okay. For table 4, we want to display the previous operation table 3, that we choose the T4, and the minimum is you can see 1 here. And now we want to apply just and allocation of this cell is 6, so we can right here is 6. Okay, and because we use 6 right here, we erase all these in the T4. Okay, now we calculate the PP and infra for the new A3 because we have been erased for T4, and this is yeah, difference for 4 and 2. Okay, now we want to find the maximum BK and BP. What is maximum, friends? Yeah, so maximum allocation is on 4. Okay, now we solve this equation in the table. Okay, now we want to continue the find the maximum penalty from BP and PK. The maximum penalty is 2. Okay, and this is the biggest number. And let's move to the next operation in level 6. What is the maximum PK, friends? Yeah, it's 5. It's just this. Okay, the result will be displayed in table 7. Okay, we display for the result from table 6 to table 7. We are right here. You can see we only have one scale process, that is we have the capacity is still 2, and we set this result into the table 8. Okay, this is the final result from farm method for the initial table, and we want to write the final table by displaying all the operation. Okay, so this is the final result for the farm for the initial program. This is the process and the cost. So we want to find the minimum cost for this initial program by just add all the costs, and we have 54. So now we know the minimum cost for the initial program is 54, and for the next step we want to check that the minimum cost is optimal or not.
Okay, transportation we familiar with this program, and we must set this program is the optimal program, or we have another more optimal program. So we send with coaching method, and like before we use this formula, and then first we let the A1 is the value of row 1 or A1 is 0, and then we add all the value of the column T1, T2, T3, T3 and T4, and then we have R for the value of the row A1, A2 and A3. Then we add in the table of the program, okay, and then we find the opportunity cost for OC with this formula. All of the unoccupied cell, we find the OC, and then we found that all of the OC value is negative. Because of this, this program is optimal program. This program is same like we calculate without coming first.
Hi friends, after we solve the transportation problem manually, starting from creating the initial allocation table of farm method to check the optimize using the multi method, the next step is to check the correctness of our manual result using the PUMQM software. This step is important to ensure that our allocation is efficient, the total cost we calculate is correct, and our solution is indeed optimal, not just visible. Well, guys, it's turned out the same. Okay friends, it's mean we can conclude that our manually work is appropriate. Okay guys, after we calculate all the tables, we have a conclusion that the assumption that total capacity equal total demand in the transportation problem is critical. It is true. So, in the transportation problem, we must know that total capacity must equal to total demand. Okay, that's all